All right, hello everybody and welcome to Train the Teacher. My name is Beth Hill and I am a community forestry specialist with the North Dakota Forest Service, but I am a big soil fan. I got my degree in it and I actually went into the career that I did because I was involved in the North Dakota Environthon, so it's a really great competition. I'm excited to have you advisors tune in and learn a little bit more. We have a big slate of natural resource professionals that are willing to come in and teach further on some of these topics. I do it a lot with soils. Now I can do it with forests, I guess. So today we're going to go through a web soil survey tutorial. I know this is a newer program that we've incorporated into the competition. We used to use those big old books back in the day, and now it's kind of streamlined, and we'll go through how to access web soil survey. We're going to learn how it works and how you could create some practice problems for your team. So starting off, what is soil? Soil is a mixture of organic matter, minerals, gases, liquids, and organisms that together support life. We have about 45% mineral matter, which is our sand, our silt, and our clay. We have 5% organic matter and then on the other side of the pie chart, we have an interchangeable 25-25 water, air. Sometimes it's more water, sometimes it's more air, depending on the moisture status in the soil. But this is just a basic on what is soil. We go into about what makes soils form all across the world. I like to break it down into a fun little acronym. It's easy for me to remember, sometimes it's easy for the students to remember better, but I like to call it CLORPT. It stands for climate, organisms, relief, parent material, and time. And those are the 5 soil forming factors. So going into climate, soils all over the world have different climate, and the moisture levels, the amount of rain they get, the heat, the cold, it all depends, or helps to form those soils. If we have, say, down in the southeastern part of the United States, we have a lot of older soils that have had time to weather because they have a lot of heat and a lot more moisture than we do up here in North Dakota. So climate is a really big one. Organisms, that's anything from our microscopic organisms to any macroorganisms like prairie dogs or dog digging in the soil. Those can help to form our soils. Relief is another one. Soils at the top of the hill will look different than those at the bottom. We have erosion factors, we have maybe a little bit more moisture down at the foot slopes. We have parent material, so out in the western part of the state, our soils are what we call residual. They formed from millions and millions of years. You can see that in the Badland formations. Whereas over on the eastern part of the state and the central part of the state, we had some glacial activity that has now become that parent material, and our soils reflect that. And lastly, we have time. Obviously, some soils are older than others, like in the case with the residual soils in the western part of the state. Those are incredibly old, where they're maybe thousands, millions of years old, whereas the glacial soils, maybe thousands, not quite as old. That's like a baby in soil time. We go into how to identify a soil, and our main way to do that is with horizons. Our O horizon is typically at the top. It's an organic layer. It can be leaf litter, humus. Usually we'll see that more in like a forest situation or wetland soil. Our prairie soils typically don't have O horizons. Our A horizon is our top soil. That's where we have our rhizosphere, our root zone, really high in organic matter, the major area where we have our biological activity. That's what makes our soils so productive. Beneath that, sometimes you can see an E horizon. We call that an alluvial horizon. That's what the E stands for. Movement, leaching of clays and organic matter. Usually this will be a little bit brighter in color. Our clays will be stripped, so it'll be more silts and sands left over. Again, we'll see those in forest soils, wetland soils, not so much in prairie type soils. Depending on where it is on the landscape. Beneath that, we'll have a number of B horizons, which we call our subsoil. These have accumulations of certain things. It can be clay, it can be sodium, it can be calcium carbonate, a number of different things, and we differentiate these B horizons out by smaller letters behind it. And then beneath that we have our sea horizon, which is that parent material that I talked about before. And then sometimes we have some R horizon, which is our bedrock. Usually we won't see this so much in North Dakota just because our soils are so deep. So when I go into the classroom, we talk about the different things to look at to determine where our horizon breaks are. I won't go too much into this, I just kind of list them here, but our main ones would be texture, so the percent sand, silt, and clays. That's a common practice that we do when we go into the classroom, teaching those kids how to texture the soil, identify, is it a loam, is it a clay, is it sandy. We go into structure, granular, prismatic, different ways that the soil looks in that horizon. Color is a big one. We do this a lot at the state competition. Color is pretty obvious. You can tell the difference in color to determine a horizon. We can have some concentrations. I mentioned calcium carbonate. We use hydrochloric acid to kind of drop it onto those horizons to identify where that calcium carbonate is located, and if it flares up, it'll see a very bubble reaction. Fragments, if we have a lot of rocks, that would be what the fragment is. If it's a really rocky horizon, that would differentiate that horizon. And then in wetland soils or soils that have some water activity, we see some redoxomorphic features, those iron concentrations and reductions. So again, that one plays into color a little bit too. But why are we talking about how to identify soils? We have soil scientists back in the day that mapped out our soils all across the United States, and they created these maps that have polygons, these little shapes. Sometimes they can look weird, sometimes they look kind of blobular, but these polygons we call map units, and these map units are comprised of what we call components, which are the soils that are within that map unit. So they grouped like soils together into these polygons, so we couldn't map out each individual soil. That would have taken a lot of time, a lot of effort, and the map would look a lot more busy and not as easy to read. Going into the soil map, you can see within the polygon there is a small letter followed by some numbers followed by another letter. That's what we call our map unit symbol. For example, the wetland you can see in the middle is F4A. F4A would be the map unit symbol. And then that symbol corresponds with the map unit name, which identifies the major components within that map unit. It has a surface texture included in that map unit name, and then any modifiers if it's gravelly, if it's saline, and then followed by that we have our slope, which corresponds with the letter at the end of the map unit symbol. So like that F4A, that A corresponds to a 0 to 1% slope. This is kind of zoomed in on it. We can see that F4A is the map unit symbol, and it corresponds to the map unit name Salvum, which is the major component, silty clay loam, which is that texture class, surface texture class, and then there's no modifiers in this one, and that A corresponds with 0 to 1% slopes. And when we have our maps, we can see how many acres within that area of interest, which is what AOI stands for, and then the percent of our AOI that map unit comprises of the entire area of interest. So what I like to do with the students is help them to learn what exactly a map unit name is, what a map unit symbol is, and then how to break down that map unit name into these different meanings. And they do this a lot at the competition as well. So I broke out this one example that F125A will do first. We have Cavor Crestbarn loams, 0 to 3% slopes, excuse me. So we ask them, what is the map unit name? That would be Cavor Crestbarn loams, 0 to 3% slopes. You have to include everything. That's the map unit name. Then we ask, what's the map unit symbol? That would be F125A. Pretty easy. What are the major components within this map unit? That would be both Cavor and Crestbarn. They're both major components within this map unit. And what is the surface texture? loams, pretty easy. And then the slope, 0 to 3% slopes. We can do it again with the one below it. What is the map unit name for this second map unit? It would be Barnes, Buse, Langhigh, loams, 6 to 9% slopes, the whole entire thing. And then the map unit symbol, F143C. Major components. Barnes, Buse, and Langhigh, all three are major components. They're included in the name because they are major. We do have our map units comprised of some minor soils, but they're in much smaller percentages than the major components that are listed. Our surface texture would be loams, and slope would be 6 to 9% slopes. Pretty easy once they learn exactly the terminology and how to put it together, and why we put it together. So next, to understand a soil map, we have to know about the U.S. Public Land Survey System, at least in North Dakota. They set this up here, and basically everything is a grid of squares that are each made up of sections, townships and ranges that are made up of 36 sections. One township measures 6 miles by 6 miles, meaning that each section is 1 mile by 1 mile, and that 1 mile by 1 mile contains 640 acres. Our section is our basic unit of the system, and township is our north to south, and our range is our east to west. So you can see, starting from that middle dot, the third principal meridian and the baseline, that's what's going to identify where our township range is. Just to the left of that circle and then up, we have our first township, Township 1 North, and then our range 1 West. Pretty simple. I wish I knew if they were asking questions. Okay, good.
I'm watching.
Perfect. So then we can further break down our section into quarters, and then that can help us to better describe where certain things on the map are located. So you can see that Township 2 South and our Range 2 West is popped out, and it's comprised of 36 sections on that bottom left-hand diagram. And you can see the way that they're arranged. They're all arranged the same way, where 1 begins in the top right corner, goes all the way to the left for 6, and then down a row, and then all the way to 12, and kind of snakes through until you have the full 36. So if we break out section 13 like they have in the diagram, you can further break it down to your northwest, northeast, southwest, southeast, and then again in the northeast corner we did the same thing. So I asked the students, what is the land description location of the star? And when we do this, we start with the smallest unit and go backwards. So we're going to do where that star is located within that northeast quarter, which would be the southeast quarter. And then you go backwards to the northeast quarter. And then you go back to section 13, and then Township 2 South, Range 2 West. So the entire land description for the location of the star would be the southeast quarter of the south, wait, did I write that wrong? I mean, you could do it even farther. I think that's what I did, where it's the southeast corner of the southeast corner of the northeast corner of section 13, Township 2 South, Range 2 West. I guess I wanted to be a little bit more specific about where that star is located. Does that make sense? Okay, good. And we'll do another example of that later on in the presentation. So like I said, back in the day, we had these really thick books full of soils, or each individual county's soil survey. This is an example of Ward County, which is where Minot's located. They are chock full of a lot of information. You could get these from your local NRCS office back in the day. They had historical information, some soil series descriptions. You can see there. We had lots and lots and lots of maps right there. And we even had interpretive tables, which were based on those soils, that the producer could go and look up the soils that they have on their land, and they could see how to best manage their soils based on what they have out there. Nowadays, we have this, Web Soil Survey, ta-da. This is a really, really awesome platform available to anybody, anywhere, as long as you have an internet connection. You just go into your search engine, you search Web Soil Survey, and this will be the first one that pops up. This will be the home screen that you'll see. It's a really user-friendly online database, and there are tutorials available on that main page if you want to become a Web Soil Survey master. In this lesson, we'll go over some basics on how to maneuver through Web Soil Survey and how you can create your own practice problem sets for your Envirothon team. Might not be masters today, but at least you'll be into the next level beyond newbie. So what you do is once you come to this home page, you are going to go and click on this green Start Web Soil Survey button, and a new window will pop up, and it's going to look like this. So you can see we have a big map of the United States. It's completely zoomed out. And then on the left-hand side, we have a few tables. And this is how we're going to navigate to the location of the area of interest that we want to look up the soil map for. They have address. You can look it up state and county if you want to be really general. We have that PLSS, that Public Land Survey System. If you knew that, you could put that in. For this example, we are going to put in the address of the Central Grasslands Research Extension Center, which is where we're located today. So if you put that into address and you click View, it's going to bring you there. That's where we're all at right now. So then to maneuver, if that's not exactly the spot that you want, I want a full section that we can kind of get a soil map for. There's a bar at the top underneath Area of Interest Interactive Map, where we have magnifying glasses, we have a little cursor hand that you can move the map around. There's a couple other tools that I'll go into a little bit later. But what I did is I clicked the zoom out magnifying glass, which is second in from the left. And that took us out to here. You can see right where that orange little crosshairs is, that's where the Research Extension Center is. That's where the address we put in. We are going to do the section just to the northwest of that. This one here. So again, at the top bar, where you have the magnifying glasses, if you go all the way over to the right, there is a red square that says Area of Interest. We're going to use that to create our soil map. And if it's just a square, you can use the one that I've used, the second from the right, excuse me. Or if you have a section where has like maybe not so geometric, there's a create your own polygon one just to the right of it. But for all intents and purposes today, we're going to use the square. So you take your point, you click, and then you drag, and then it'll create that square. And as soon as you release, it's going to zoom in to your area of interest, and it's going to be dashed with blue lines. So that is your area of interest, or your AOI. And then if you can see right at the top, we have Area of Interest tab. Right next to it is the Soil Map tab. We are going to click on that. And it's going to take us to this page, where it's the exact same square, but now there are orange polygons drawn on the entire thing. And that is our soil map. Those are our map units that we discussed earlier. And this is what we're going to be working with today. So just to start off, I thought it'd be nice to do another land description exercise. So let's say this is section 36. This is range 70 west and township 138 north. I looked it up. It's right. So we are going to try to identify where that star is located. It's on a polygon down in kind of like the southeast part of the area of interest, but we want to get real specific. So first what we do is we cut it into quarters, and then we cut it into quarters again in that southeast quarter, and then we are going to cut that into quarters again, and then again. So what is the land description of that star? Anybody want to guess here?
It's southwest to the northeast of the southeast of township 138 north, range 70 west.
That is very, very close. We forgot the section.
Section 36.
Yes. So like Calla said, it is the southwest quarter of the northeast quarter of the southeast quarter of of the southeast quarter of Section 36, Township 138 North, Range 70 West. Oh, I went too fast. So next thing I would ask is, what is the map unit symbol of the polygon that that star is located on? And if you might not be able to see it in the recorded video, but it is C3A. And then next I would ask, what is the map unit name of that map unit? And it would be Parnell Silty Clay Loam 0 to 1% slopes. And we would be able to tell that by corresponding the map unit symbol to the map unit name in the table just to the left of the map. You can see it on the left-hand side. And then I mentioned that we can have some pretty handy tools in that toolbar up top where we have the magnifying glass, the cursor, that kind of thing. There's a circle that is blue with an eye in the middle of it, and that's our identify tool. So what I did is I wanted to identify this main really big polygon that kind of runs through the entire center of the map. So what I did is I clicked the identify circle and then I clicked inside that polygon, and it came up with this identify table beneath the map. You have to scroll down a little bit to see it, but it's going to tell me what is the latitude, longitude of that point. We have a few more information here. It has the map unit name of that map unit, which is Lair Waback Loams, 2 to 6% slopes. It has the map unit symbol, the soil survey area symbol, so that tells us which county it's in, and then the dates that the map was photographed, which was April 18th, 2014 to August 27th, 2016. So there's a lot of information included in this program. It's just learning how to find it. So next, I want to learn a little bit more about that map unit, that Lair Waback Loams 2 to 6% slopes that we had just identified. So I scroll back up, and I click on my table to the left. I'm going to click on that C819B, which corresponds to that Lair Waback Loams 2 to 6% slopes. You click on the blue link, and it's going to pop up this table on top of your map. And there is a ton of information included in this as well. It might be hard to tell, but I will read off some of the information on here. It starts out by saying the map unit symbol and the map unit name again, and then it tells you where the map unit sits on the landscape. So it tells you about the elevation that we have on the map. It tells you what the mean annual precipitation, the mean annual air temperature is, the frost-free period, farmland classification, and then it goes into the map unit composition. And like I mentioned, we have major components and minor components. It starts off by listing the major components and a lot of information that was detailed about those major components. So that first one was layer. It sits on the rises, it talks about the landform position, it's on the back slope. The parent material, which is a loamy alluvium over sandy and gravelly glacial fluvial deposits. It goes through the typical profile that you'll have for that layer soil, and then some more properties and qualities of that site, such as slope, depth to restrictive features, any runoff class. Like I said, a lot of information. And as you scroll down, it does the same thing for the Waback soil, which is another major component. And then beneath that, we have our minor components listed, and it will give you a little bit of information about those minor components, such as the percent of the map unit. We have a bodal soil that's 10%. We have Appam soil, which is 5% of the map unit, and then Tonka, which is 1%. So much less than the Waback and the Lair. And then it just goes into where these are on the landform, how it corresponds within the map unit. So like I said, a lot of information. It can be a little daunting at first, but the more you play with it, the more you explore, the easier it's going to be. So I'm going to go back to our main map, and what we're going to do next, instead of looking at our soil map, we're going to learn how we can use these soils. And so that would require us to go to the Soil Data Explorer, which is just to the right of the Soil Map tab on the top. You can see that arrow there. Click on that.
We have one question, Beth.
Oh, yes, sorry.
During the competition, will students be using the web soil survey, or will they have handouts given to them?
It will be the same as it's always been.
Yes. So they're going to be given handouts. So this might be,
This is just a tool.
yes, this is just a tool
Making
to
sure that's-
learn how to use web soil survey. So when they do have the handouts, they understand how they are composed and where they come from. This is like a really in-depth going from the information that would be in a soil survey book, and that is now available in the web soil survey. So we make it really easy and streamlined. I know when I was in the Envirothon competition, you had the whole book, and you had 10 minutes to find the information within the book that you needed to find. And we could do it, but it took a lot of teamwork. So this is a lot more streamlined, a lot easier, I think. And yeah, I think, did that answer the question? Okay, cool. So this, I guess for all intents and purposes, this is to teach you how to use web soil survey so you can teach your students so they can get some experience on what these handouts are going to look like. And then you can create your own practice problems to get them ready for the competition. So, like I mentioned, we are going to go to Soil Data Explorer up at the top. And it's going to take us to this page. You can see the map looks the same, but on the left-hand table, there are a bunch of tabs that you can click down on, and they're grouped by, I guess, land use. We have like building site development, soil health, vegetative productivity, water management, those kind of things. So these are the interpretations that you would see right before the maps in the typical soil survey book that we used to have. And these are taking into consideration the suitabilities and limitations of these soils and helping you to better understand, is this a good spot to put a house with a basement, or would it be good for irrigation, and what capabilities the soils would have to perform under those. So I'll go into a couple examples. These would be similar to examples that you could create for your students. So what I did is I clicked on vegetative productivity on the left, and I clicked the first interpretation called crop productivity index. And I clicked nothing else underneath that. I clicked view rating, and it came up with this colorful map. So what do these colors mean? I think it'd be easiest to just scroll down, and it's going to give us a table of all the soils that are in our map, and it tells us the rating for the crop productivity index. So a question that I often use this interpretation for is farmers typically, they don't crop on soils with a productivity index under 50 due to reduced yield production and other limiting factors. So knowing this, are there any map units that would be unsuitable to farm within this map? So what the students would need to do is look through the rating column and see if any of those numbers are below 50. And if they are, then they would write it down, and that would be the answer. So in this one, we actually have 7 soils that have a productivity index that are below 50, meaning that this plot of land probably shouldn't be cropped. And I think that's why at the Central Grasslands a lot of it is put into rangeland, because it can be more productive in that matter. But if you look just through the ratings, we have like a 20, a 36, a 49, 46, 41, 23, 26. And then they would have to compare it to the ones underneath. This particular map that we made is in between 2 different counties. And so it's the same map units because they're in the same soil survey area, but you just have to double check that nothing was left out in the bottom part of that table. So the answer to that question that I just asked would be 3CA, or C3A, C156F, C311B, C376C, C819B, C870E, and C874C. And when I'm reading off those, as somebody who understands the different slope factors, if we have an A, that means it's a pretty level ground, which would be good to farm on. Something with a slope of F is going to be super duper steep. We definitely don't want to crop that. And so a further, like working with this and going through and understanding the different soils that we have within these maps, we can start to identify, okay, yes, that's a really steep soil. We don't want to farm that, and help them to kind of understand a little bit better about what these interpretations mean. So then a similar question we could ask, in which map unit could they expect to produce the highest yield? And underneath the table, you can see there's a description that goes into how exactly they put together this interpretation. And it says ratings go from 0 to 100. The higher numbers indicate higher production potential. So that means the higher the number, the better yield could be expected from those soils. So by looking at our column where it says ratings, I am looking and it looks like the highest rating we have is 83, and that corresponds with map unit symbol C210B. So on that soil, we could probably expect a higher yield than any other soil on the map. Any questions? Good?
I want to see if that was
Oh yeah. A little sandy, a little gravelly. Okay, so what I did next is I opened up a different interpretation. This time it is under the water management tab. I thought it'd be useful to look up some water interpretations since that corresponds to the current issue. This one specifically is general sprinkler irrigation. So we want to put a sprinkler irrigation system out on this land. Is that a good idea? Can we get the most bang for our buck by doing this, or should we maybe not? So an example question here we could do is how many acres in the AOI are not limited for sprinkler general irrigation? We would see that this map is color coordinated, and by clicking on the legend tab up next to the magnifying glasses, there's a legend tab. Click on that and this map legend will pop out onto your screen. We can see that in the legend tab, we can see what each color on the map represents. It looks like red is very limited, yellow is somewhat limited, and green is not limited. So to answer that question, we would want to look at the map units colored green, which would only be C375B. That's the only map unit on here that is green. And you can see there's a small one on the left that is kind of cut out. That still is C375B. So if the question were how many acres in the AOI are not limited, we would need to scroll down to the table below where it lists all of the map units and exactly why they were rated somewhat limited, not limited, or very limited. The second one down is that C375B, that Krem-Flaxton complex 0 to 6% slopes. We can see in the ratings column it says not limited. Because it's not limited, there's no rating reasons. And then we go into the next column over where it says acres in AOI. We have 102.0. So that would be the answer to the question, how many acres in the AOI are not limited? Make sense? Okay. Next question that we could ask would be, in which map units are the soils very limited for sprinkler irrigation, and why? So looking back at the map, we have 3 polygons, one in the top right corner, one in the bottom right corner, and then one on the left-hand side that are red. That indicates are very limited. So then we would scroll down again into the table, which looks like this. What I did is I clipped the map units that we were specifically looking at, so they won't always be right next to each other. I think they go alphabetically or numerically. But we are going to look at the rating reasons column to answer the why. So we already have the which map unit symbols are very limited, which would be C3A, C156F, and C870E. Those were the red polygons on the map. The reason why would go into each individual component and then the restrictive features that would make it not suitable for irrigation by sprinkler. So, for example, in that Parnell silty clay loam, we have 86% Parnell in that map unit. Some of those reasons why it would not be good for sprinkler irrigation would be depth to saturated zone, ponding, and slow water movement. So, We don't want to put more water on an already ponded soil. And you would do the exact same thing for the other components within that map unit. So you'd look at Valors, you'd look at Tonka, Southam, and Heil, and Mary's Land, and you would see if any of those other reasons are different than the ones listed in Parnell. So I'm looking here, in Southam we have excess salt, so we'd have to include that as well. And in Valors it has excess sodium as well, so we'd write that down. So the answer to which map units are very limited for sprinkler irrigation and why, the first part of that answer would be C3A, depth to saturated zone, ponding, slow water movement, excess salt, and excess sodium. And we would do the exact same thing for the other two map units that were very limited. Make sense? Good, good? Great. Okay. So, I went back, scrolled back up to our map. Now we are going to look at some more interpretations. These are focused on the soil properties and qualities. So that tab is next to the suitabilities and limitations for use tab underneath the Soil Data Explorer tab. So you can see my little arrow. You click on that. Maybe. There we go. And it's going to pop out the exact same looking thing. It'll be a normal color. I just included an interpretation right away. But if you look to the left, I clicked on soil chemical properties. And I am looking at electrical conductivity as a interpretation that we want some information on. Do these soils have salts in them that would help to, or would impede our plant growth? So in this interpretation, you do need to add some additional information in the left-hand column. The only thing that I changed was there's a top depth required and a bottom depth required. So top depth, I did 0. We want to look at our surface. So 0, and then I did 12. So 1 foot of soil, we're going to look at the surface electrical conductivity. So then you click View Rating, and it's going to pop up a map like this. It's all one color. And sometimes red means bad, and sometimes red just means it's grouped together. So in this case, if we clicked on legend, we can see that red means the same value, not necessarily bad. And we would know that by also scrolling down and looking at our table. And so our rating is in decisiemens per meter, and it looks like every single map unit has a rating of 1.0 decisiemens per meter. So one question that you could ask that is pretty general about this interpretation is, what is electrical conductivity and in what units is it measured in? And that information, if they didn't know off the top of their heads, they could look in the description of the interpretation and copy it word from word from there. So you can see in the description I underlined 2 different sentences. So as far as what is electrical conductivity, it's a measure of the concentration of water-soluble salts in the soil. And that's taken straight from the description. And in what units is it measured? It says decisiemens per meter at 25 degrees Celsius. So copied it straight from the description. Another question you could ask would be, how do salts affect plant growth? And that again is included in the description, if the kids didn't know exactly what it was beforehand. So, copying it word from word, salts may interfere with the absorption of water by plants because the osmotic pressure in the soil solution is nearly as high or higher than the plant cells. And that would be the answer to that question. And then, using the table, we could create a question like, many crops we grow in North Dakota are sensitive to salinity. Sensitive plants and seedlings of others may show injury when the salinity is greater than 2 decisiemens per meter. In which map units could we expect to see injury or inhibited plant growth? Any ideas? If a rating of 2 decisiemens per meter would create injury or impede plant growth, and we have a rating of 1 in every single map unit, would any of them be affected? No. So the answer would be none. Easy peasy. And then another feature that Web Soil Survey can do is you can export these maps and create handouts exactly like you would see on the state Envirothon test. So to do this, you would go up to the right-hand corner, top right-hand corner. There is a printable version button that you click. It's going to pop out this little square, and you can create a custom title. So this one I put as electrical conductivity example. And then you click view, and it's going to pop out a PDF. Oh, there's printable version. And it's going to pop out a PDF. I kind of clipped it together so you could see it all in one, but it shows the map, it shows the map legend, information on the map, the table that was underneath the map on the web page, the description of the interpretation, and then rating options, how they put together the rating. Any questions? Okay, that's all I got. Hopefully that will help you to at least learn a little bit about how Web Soil Survey works, maybe shy away from using the books, but still learning exactly how they are set up and how you can create examples that will help your students throughout the year prepare for the state exam. If you have any questions or would like some help, a little bit further instruction or some help on creating some examples, you can email me beth.hill@nbsu.edu. I'd be happy to help or come into your classroom, anything like that.